So hello and thank you for joining us today for our webinar about the Master's Programmes in Applied Instrumentation and Control Engineering and Applied Data Science and Engineering. I'm delighted to welcome our host today, Peter Wallace, who will discuss information about the programme and the learning experience here at GCU. Do feel free to ask any questions in the chat box that's on screen. And with that, I'll hand you over to Peter Wallace, who is our programme leader for the Applied Instrumentation and Control Engineering.
Yeah, excellent. I've got my slides now.
Okay, Peter, we have 6 attendees in the webinar, and if you want to go ahead with your presentation, we can take questions as we go along. Probably best for you to address any questions for yourself at the end, just so it doesn't interrupt your flow. But I'll
Right, so.
Thank you.
Okay, and I'm driving the slides from here. Okay, so welcome to the webinar. That's the two programs we're going to look at. I am Peter Wallace. I'm the program leader for the Instrumentation and Control, and my colleague Dr. Nicolita runs the Data Science and Engineering. And this presentation will cover both of them. So to begin with, the MSc program or NMC programs in the UK are generally required to be accredited by the Engineering Council. The career grade for a professional engineer in the UK is the acquisition of chartered engineer status, and that is done by a mixture of qualification, of formal learning and experience. And both of the programs that I'm going to talk about today are fully accredited by the Engineering Council through two of the institutions. There's the IET, which is the big one that covers lots of things, and the Institute of Measurement and Control, which is a more specialist organization, specializes in what it does in the title. And those are essentially, parallel routes through to chartered engineer status, which are afforded by these programs. And that's an important career step for an engineer in the UK framework. A master's program in the United Kingdom is normally one full calendar year of work, 12 months. It's a busy 12 months. And our programs here are available as a 12-month program for students starting in September, so that's the autumn trimester. And also for students starting in the January trimester, they can cover the same course of study, but that will normally take something more like 16 months because there's a break over the first summer vacation period. It may be relevant to some of the attendees here, but we also offer both of these programs in a distance learning mode for students who are already beginning their careers, who are already in employment, and they can study entirely remotely on an extended timescale, anything up to about 5 years. What are these programs for? Students will tend to have backgrounds in some kind of engineering, typically electrical or electronic engineering. Physics is often is a very suitable background as well. Some of our students come from. Depending on the individual's background and interests, these programs may also suit mechanical engineers, chemical engineers, computer engineers, or computer scientists. That last point especially applies to the data science program. So don't be put off by the idea that your background doesn't necessarily fit with these programs. If you're interested in one or other of these programs, then give us a call, drop us an email, and let's discuss your background, preparation, and interest. Where have international students come from in the past? Of course, this is history. We have no, there's no requirement to hail from any of these places as an international student. We'll be interested in applications from anywhere. But in the past, we've had a lot of interest. People have successfully completed the program from West Africa, Nigeria, Ghana, from India, Pakistan, Sri Lanka, Bangladesh, from Southeast Asia, Middle East, North Africa, and indeed Europe, plus, of course, our own domestic students. In addition to the formal teaching, our programs, of course, are interested in preparing our students for future career, and we build various other elements into the program, and that will include visiting lecturers who might hail from industrial partners or who might be alumni. And in the recent past, we have had visiting lectures from industrial partners covering technical topics. We've had visitors who are quite senior industry figures talking about career progression and describing how a progression into management is a not untypical career path for someone who starts as a technical engineer. And we've also had alumni, our own students, coming back, speaking about early career issues and their path into industry from academia, from education. There'll also be opportunities to make site visits to industrial partners, which will give us the opportunity to look at industrial scale plant and equipment and operations. And our MSc projects are often completed in association with an industrial partner, with some degree of participation from an industrial partner. Further to this employment and employability topic, I have maintained a group on LinkedIn, which I restrict to our alumni from the Instrumentation and Control MSc. I believe my colleague is doing something similar now with data science, but this program has been running longer. It has a bigger family of alumni. And I did a fairly sort of non-scientific survey of my group members, my alumni who have stayed in contact, who of course tend to be those who are still working in the discipline. And I've looked at a fairly reasonable number of international profiles, and it looked as if something like a quarter are based in UK control and instrumentation positions, so as professional engineers following on from their formation at GCU. There are a few students doing research in the UK, so that's PhDs. That could use an upgrade because I know of at least one who now has a teaching position and has been successful in getting some research funding. Nearly 2/3 are working in a professional capacity abroad. So that could be that they have returned to their home country with the upgraded qualification, or it could be that they've gone to a third country. And there's a fair number, my figure here is 8%, in the higher education sector abroad. And that tends to be because we've had a few people who have been sent by their own institution, a university typically, to upskill and then bring that back as part of the development of the faculty in that institution. So my slides have changed color now, and I'm now going to focus on one of the programs and then the other. So Instrumentation and control engineering is a multidisciplinary field focused on the science and technology of measurement, operation, and the control of industrial processes. It bridges the gap between the physical processes and computer-based automation, designs systems that ensure safety, reliability, efficiency, and optimization of operations across a wide range of sectors, including energy, manufacturing, chemicals, food and pharmaceuticals, utilities, and transport. It's almost a universal discipline. Wherever there are other engineers working at scale, they are liable to need some C&I engineers. What's our place in the landscape? There are a certain number of UK-based programs, which will include either the words control or instrumentation in their titles. Some of these concentrate almost exclusively on the mathematics of control theory, and others are very strongly based on electronics. None have quite the same balance of content as our program. There's room for everybody, but there's a place for us, and we occupy that place. It's interesting to note that recently we've had a group of industrially sponsored students who were sent to us by their employer as part of their graduate program, because they looked at the options and decided that our balance of contact was what suited them. So that certainly gives us confidence that we are doing something useful. So what will you study if you're on the instrumentation program? We split the program into 2 trimesters, which means a control trimester and an instrumentation trimester. And that makes it easier to begin either in January or in September without any detriment to your experience. So in the instrumentation trimester, the first 2 modules will cover the basis of turning sensor signals into meaningful and reliable digital information. And the third one, the measurement systems, takes us onto a more industrial scale, looking at larger problems, and also introduces us to industrial equipment like PLCs, programmable logic controllers. The final one there, system health management. System or asset health management is a vital concern in industry and infrastructure everywhere. And control and instrumentation engineering is a crucial core discipline for that kind of thing. And there's a flavor of that running through the program. Next page covers the control trimester. 3 successive progressive control modules here. The first one will cover classical control methods for single input, single output systems. Second module goes on to state space methods for multiple input output systems. And the third module, the model predictive control, that represents the state of the art in the control of complex systems. The fourth module, their professional practice, covers a set of universal topics which are required as part of the formation of any professional engineer and will be built into any master's program. And finally, the project is an opportunity to concentrate on a single problem for a full trimester as an individual. And you write a dissertation and you will give a presentation on your work. As you said before, there's a variety of possibilities for a range of external input on the project, depending on the interest of the student and what the present external opportunities are. And there's my email address for further inquiries. Slides have changed colour again. Now we'll talk about the master's program in data science and engineering. So data science in this context is the application of statistical methods, machine learning, computational tools to solve complex technical problems and optimize physical systems. and it will bridge the gap between the traditional engineering disciplines, be they mechanical, instrumentation, or chemical engineering, and novel data-driven analysis, which will produce to improve product design, predict maintenance needs, and improve operational efficiency in whatever your processes are. Where do we fit now? Our title is Applied Data Science in Engineering. Data science is a very fashionable topic at the moment, but industrial experience, including from our own staff, some of our own staff who have come to us from an industrial background, indicates that the data science tools need to be used by people who understand the industrial context if they're going to provide a real advantage. And our data science engineers gain knowledge of how data can be acquired reliably in real-world situations. We have, in fact, had testimony of this from our own completing students, some who have come in with a very mathematical computer science background and questioning why they need to know about the engineering, why do they need to know about these oily pieces of metal. But by the end of the year, they're saying, yes, now we get it, now we understand. So yes, it gives us confidence that we're on the right lines. That's the program for the data science program. A couple of these modules you've seen before, the data capture and the system health management, are in common with the instrumentation program, and much of the rest is bespoke for this program. Again, there is something of a system health management flavor here. One of our major industrial partners is an organization which has provided hundreds of assets in the multi-million or multi-million pound bracket to customers worldwide, and they are developing systems which allow them to monitor these big assets in place in real time and look after their optimal operation for the customers. Of course, they're not doing that as a charitable service. As well as selling the original equipment, they sell this monitoring service. Servitization is the buzzword for that. And both disciplines, control and engineering and data science, are at the core of providing the service in a useful way. And the program leader for, excuse my typo. I'll read it out. The program leader for the MSc in Applied Data Science in Engineering, excuse me, is Dr. Octav Nicolita, and there's no typo in his email address there, so he's the person to contact directly if you're interested in that. And that's me at the end of my presentation. So I'll field any questions.
Thank you, Peter. That was really informative. We have a few people in the audience. If anybody has any questions, now is the time to ask. If you can just write that into the chat box, and we can address those. If you have any other questions that come to mind later on, do feel free to email those in to us, and we will be really happy to pick those up for you. So we'll just give people a couple of minutes to type up their thoughts and any questions. Thanks, Emmanuel. Do you have any questions for Peter directly that he could answer? While we're waiting, just to remind everybody in the session, you can browse and sign up for any other sessions this week that might be helpful to you. We've got lots of sessions on different academic areas. We've also got lots of support areas presenting, things like admissions, CAS and visa, funding, finance, etc. So do browse the link. I've posted it up and pinned it to the top of the chat.
I've just seen Emmanuel's comment, so well, thank you too. Thanks for attending.
Okay, I don't think we have any other questions coming in, Peter. So I'd just like to thank you for coming and delivering your presentation. I think it was really interesting and helpful, and I think people aren't asking any questions because you covered everything off really thoroughly. So I'd like to thank everybody for attending. I do encourage you to attend as many of these sessions as you can this week. So with that, I think we can end the webinar. Thank you, everyone.
Thank you.